Okay, they give us here ABCD is ABCD, the big quadrilateral on the outside here is a parallelogram. They say that DP and BQ are perpendicular to the line AC. So we know that that's 90 degrees perpendicular, 90 degrees on both sides of that. Prove with reasons that ADP, this little triangle here, is congruent to CBQ. Well, how are we going to prove congruencies? We've got lots of different ways, but we can do it this way. We can go in these two triangles, DAP and BCQ, that angle up in the corner there, and that angle down there, BCQ, they must be equal. It's alternate angles because AD is parallel to BC. It's a parallelogram. We know that AD equals BC because it's opposite sides of a parallelogram. So we've got an angle, we've got two sides here, but we were given that this is perpendicular here, so that we've got this angle APD and this angle BQC. It's given that it's perpendicular. It's given that it's 90 degrees. Well, we have just got two angles and a corresponding side. You see, the side is opposite the 90 degrees. Because of that, we can say triangle ADP is congruent to triangle CBQ because of angle, and a corresponding side. Why is PD parallel to QB? Well, I figure if we look at why are these two lines parallel? Well, that's 90 degrees right in there. And right here, DPQ and BQP are both 90 degrees. Well, those are alternate angles. We have two angles the same. Right there, those alternate angles are the same. It makes those lines parallel. Prove with reasons that PDQB is a parallelogram. I can't remember how I did it. Let's take a look. Well, we know that PD equals BQ because of congruent triangles. These two triangles are exactly the same. Then these sides must be exactly the same. They're opposite the same angle here, right there. The alternate angles that we proved is the same. So they must be the same. And PD is parallel to BQ. We just proved that. Well, then we can say PDQB must be a parallelogram because then we have a pair of sides that are equal in length and parallel. And that's one of the conditions, one of the proofs for a parallelogram. So there we go.